So we left off on this one. And our goal here is to make the left-hand side equal the right-hand side. And you guys are going to have to just start using your imagination on things. So what would y'all like to do? If we do it wrong, we'll start over. Why not? You just got to try something. You have to try something. Any other suggestions? I'm waiting on y'all. Because I ain't going to be the one doing your homework. So y'all better start using your imagination and thinking of things you can do. And I ain't going to be the one taking your quiz. So you want to put these pieces together? Like, well, why not? Why couldn't you do that? I don't know why you couldn't do that. So what would we give sine squared? Do we give sine anything? No. That's all sitting over cosine. We could do the same thing on the bottom. What do we give this cosine squared? I forgot to give this thing cosine, didn't I? I'll just give it to it out front. Doesn't matter where it's at. What is this cosine given? A 1, but nothing we need to write on a piece of paper. What's it sitting over? Sine. Say it again, Zach.
Since it's sine squared, if you can take away a sine,
No, that's like x squared minus x, bro. Don't be that kid. You didn't make that mistake in algebra 1. Don't make it in calculus. What Zach asked was because sine squared minus sine, sine. Are those alike? You know that. And you know you can't do x squared minus x, but when things start looking different, guess what you do to all the rules you already know? You just throw them right out the window. You're not supposed to do that. You stick with what you know. It hasn't changed. It will not change. I've said for years math is cumulative. That means if you learn a procedure once, it applies from then on. Oh my God, you just killed a cat. You want to cancel that out? You can't do that. All terms have to have the factor. Does sine have a cosine? All terms have to have a factor. At least you're thinking. 2 wrong suggestions is better than no suggestions. It's okay if I tell you you're wrong. The reason you don't know what to do is because you spent your whole life punching buttons on a calculator. How do you divide by a fraction? Do you see a fraction being divided by a fraction? So how do you do that? Flip the bottom piece. Flip the bottom piece, kids. Leave the top as it is, sine squared theta minus sine of theta, sitting over cosine of theta. It's going to be multiplied by sine of theta, goes up top, we're flipping it, over cosine squared sine theta minus cosine theta. Waiting on y'all. This is that. Missing a piece, isn't it? Forgot about the cosine of theta. It's cosine theta, sine squared theta minus sine theta over cosine theta. Where are you getting sine cubed? Oh, you want to do the distributive property. Just something so simple. So simple, it's right there. Quotient identities. It's a quotient identity. It's right there too. Sine over cosine is tangent. That allows us to take this piece right here and kind of pull it off the side and say it's tangent. For those of you that are watching on a video, sine over cosine is tangent. If you ever watched Lord of the Rings, you understand that meme. If you've never watched Lord of the Rings, you suck. Or I'm a nerd, which is probably a given. One of the two. So what we're going to do is we're going to take this piece right here. We're going to say that's tangent. I'm just going to throw it out front. Let's see what we got. We have cosine of theta, sine squared of theta, minus sine of theta, sitting over cosine squared theta, sine theta, minus cosine theta. I know what to do. I'll give you all a minute. If you hadn't come up with anything, I'll try and give you a hint. I do know that this piece is going to somehow turn into tangent. Because a tangent times a tangent would be tangents. Huh? Here's your hint. Cosine is x, sine is y. Think about it in terms of x and y. There's a hint. Huh? Oh, I guess I heard something else. Commandment number 1. Pull. Pull y's from the top and x's out of the bottom. And you'll probably create something where you can cancel something out. So why is the first commandment? You can pull it, pull it. What can I pull from the top? From two? There's two distinct pieces up there, is there not? What can I pull? I can pull a sine. If I pull a sine from cosine theta sine squared, what's left? cosine sine, right? Minus 1. What can be pulled from both pieces in the denominator? Cosine. What's left? Cosine of theta, because I pulled one of these cosines. Sine theta minus 1. Ta-da! What do you get to cancel? There we go. Welcome to analytical thinking, kids. What's sine over cosine? Ah, so cool. Tangent theta times tangent theta, which is tangent squared. See, that wasn't so bad. Actually, it was horrible, wasn't it? You just got to know these identities like they're your second language. Well, not even your second, your first language. I mean, they have to be by heart. If you took that quiz, which I got passed back, with just 5 minutes of cramming, and you thought that was good enough, it's not good enough. You got to be here, first language. All right. So I guess if I asked you guys how you feel about this, it would not be a good reply. It really isn't. 1 down, 3 to go. Actually, I know the next one's pretty easy. So we're going to make this guy look like that guy. Anything you learned yesterday you could do to make this guy look like that guy? They even had a vocabulary word associated with it. Multiply by the conjugate. What are you going to multiply the numerator and denominator by? 1 plus sine theta. And I'll let you guys do that for a few minutes. That's your first step. Remember, Jesus would FOIL the denominator. He says a lot of stupid things. You hadn't done anything wrong yet, Riley.
I know, but can you do it a different way than foiling the bottom?
Well,
could you take that thing out of the top and then cancel them? Like take the cosine out of the top and then you have sine of cosine plus 1 and then that matches up with the bottom so you can cross this out and you just have 1 minus sine on the bottom.
I'm not saying there's not another way of doing it.
Like instead of foiling these, could you just take the cosine out of these 2 pieces and then cross those 2 out?
Thing is, they're not saying, what is 1 plus, how much is minus?
But that.
Oh, right there? Yeah, that's ultimately what you're doing.
I could do that instead.
You basically want to reverse your factoring, right? As in, you're going to reverse your factoring, you're going to cancel out the 1 plus.
I mean, I still multiply these together and then I just factor that out.
So you want to reverse what you just did. You're going to go nowhere with it. There's no point in doing something if your next step is to immediately reverse it. Because you're going to fact that you do, right? Don't distribute in the first place. I told you guys, don't distribute in the numerator. Unless you absolutely have to. That's everyone else. They're ready to distribute to the numerator. I think what you're missing is your 1 minus sine squared. That's what you have to manipulate. There you go, you figure it out. There was supposed to be a big decision like this. Yeah, I'm going to work through this one. Usually you do not distribute the numerator, kids. I'm pretty sure I said Jesus would not distribute the numerator right before I told you guys to do this thing. You can rewind the video if you want, but I'm pretty sure I said Jesus would FOIL this, but he would not distribute the numerator. And what did y'all turn around and do? That wasn't me telling you what to do. That was God. That's a little sacrilegious. I apologize. Plus, this isn't church, is it? Looks, most of you guys got the bottom piece right. 1 times 1 is 1. Negative sign. Whoops, right there. Negative sign, positive sign, no sign, minus sine squared. And then what you're supposed to do is you're supposed to think about this thing. That's what you're supposed to be thinking about. You just jump that guy over. Cosine squared of theta is 1 minus sine squared of theta. So that means this piece is really just a cosine squared. And I know that we talked about how to handle this yesterday. Throw that away and throw that away. And there you go. Now, is there another way of doing this problem? There is, but I'm not going to teach it. But some of y'all were wanting to, what you were doing was you were distributing and then you were immediately reversing. And you were going to cancel out the 1 plus sines of theta, which got you right back to where you started in the first place. You need to see that. You know, if you don't believe me, try doing it your way and see what happens. All right, now we got this one. Establish the identity cotangent squared of theta is equal to the cosecant of theta minus the sine of theta sitting over sine of theta. Normally I say make left hand equal right hand, but I wouldn't on this one. I'd make the right hand equal to left hand. So on this one, I'm going to make the right hand equal to left hand. Because the right hand side's the ugly side. I don't think it's actually that bad of a problem, but I've been wrong about things before. Be like SpongeBob, use your imagination. I don't know when I talked about it, but early on your notes I talked about doing something with fractions. Should I have the notes? I don't know if you wrote it down or not, but I did. Talked about that yesterday. You know, kids always say, how do I know what to do when I need to do it? Because it looks familiar. That's two things in the numerator, one thing in the denominator. How many things in the numerator? And the big deal is how many things in the denominator. Break the fraction apart. See what you can do with it. And maybe do a rewrite. You've got reciprocal identities you can use. And if you're sitting at home watching this, which nobody watched a video yesterday. Tanner, Elizabeth, that's you. Crawford, you done?
If the cosine squared on top of it, I don't know how to make the sine squared on top.
You have a cosine squared on top? No. You went down the wrong direction. All right, does everybody have this cosecant theta? Or maybe I'm going down the wrong direction. I am. No, I'm not. Everybody have that? What's cosecant? 1 over sine. Cosecant is 1 over sine. I don't even know that I needed to modify that, to be honest with you. Supposed to get the cotangent? Yeah, I needed to do that. What's a half divided by 4? Okay, let's do this a little easier. What's a half divided by 2? 1/4. Because all you do is you move that piece right there and change it to multiplication. That's all you do. Where does division happen? In the denominator. It doesn't need to be here. It needs to be right there. You can always shift something up when it's division and change it to multiplication. It works every stinking time. What's sine times sine? What's 1 over sine squared? Cosecant squared. 1 over sine is cosecant. 1 over sine squared is cosecant squared. This is cosecant squared of theta minus 1. You got a Pythagorean identity. It's probably the third one we wrote. This is cotangent squared. You have a Pythagorean identity. This is what? Cotangent squared of theta plus 1 is cosecant squared of theta. Hopefully you can see this. We just take away the 1. Isolate. By the way, what happened to this guy? No, doesn't happen to that guy. Let's cotangent squared of theta. This is why Mr. Milbrath always said calculators make you dumb. He never learned patterns of numbers. And a lot of the stuff I've been doing today, what have I applied? I've applied patterns from working with numbers. I know how to work with fractions. I apply those patterns. I know how to actually do division. I apply that pattern. So if I show you something like this, that's a pattern you need to just accept and do. Because it's a heck of a tool. Otherwise, you got to change to a fraction multiplied by the reciprocal, which is doable. But this is so much quicker. All right, so you guys are like, what, 0 for 2 there? Huh? Oh, you got one? That's better than most. This is one of the easiest ones on here. I'm just going to let y'all try it. If you're confused, use your reciprocal identities. One of the very first things we did was we rewrote things. I know cosecant can be rewritten. Nothing's stopping you on a piece of paper from changing things in X's and Y's. Sine X, that's fine. Boys and girls, you have a sine in the denominator, and you have a sine cubed in the numerator. I know that's what you have. Those simplify. You have a sine cubed up top, you have a sine in the bottom. Those simplify. You got x squared up top and x in the bottom, you know what to do. That's why I said it doesn't hurt to think about these things as x's and y's. Sure, there's nothing wrong with it. I think there's something wrong with that.
So we just figure out those constants.
That's what it is. All right, for those of you at home fast forwarding through things, because that's what you'll do. Cosecant is 1 over sine of theta. And then we have sine cubed of theta. If you just focus on these two pieces right here, that one's gone. That exponent becomes a 2. You have 1 minus sine squared of theta. And at least 3 times in our notes, this was talked about. That's cosine squared of theta, kids. That was the goal. Now, obviously, you guys don't have a book. But, so you're not doing that. You're doing this. Very own identities. Tomorrow's going to be a work day. All right, tomorrow will be a work day. Thursday, I'll give you a practice sheet for a test. Friday, I'm going to give you a test. That's my plan, anyways. Got 10 minutes left in here. If you want to get started and ask me for help, by all means, ask me for help.